Hey everyone! Today we're diving into matrix multiplication, one of the most fundamental operations in math and computer science. This might sound intimidating, but it's actually really elegant once you see how it works. Matrix multiplication is everywhere, from training AI models to rendering 3D graphics. Let's break it down step by step. Here's the flow of matrix multiplication from start to finish. First, we take two matrices and validate that their dimensions are compatible. The number of columns in matrix A must match the number of rows in matrix B. Then we enter a nested loop process where we multiply each row from the first matrix by each column from the second matrix. We sum up those products to get each element in our result matrix. The final result has dimensions based on the outer dimensions of our input matrices. Let's see a concrete example with real numbers. We're multiplying a 2 by 2 matrix A with another 2 by 2 matrix B. To get each element in the result, we take a row from A and multiply it element by element with a column from B, then add those products together. For example, the top left result is 1 times 5 plus 2 times 7, which gives us 19. We repeat this process for every position in the result matrix. In practice, you'll use NumPy for matrix multiplication because it's incredibly fast and optimized. There are two main ways to do it. You can use the @ symbol operator, which is clean and modern, or the dot function for the traditional approach. Both give you the exact same result. NumPy handles all the complex looping and optimization under the hood, so your code stays simple and runs lightning fast. Now let's implement matrix multiplication from scratch to really understand what's happening. We use 3 nested loops. The outer 2 loops iterate through each position in the result matrix, and the innermost loop does the row times column multiplication and accumulation. This is the classic algorithm with O(n cubed) time complexity. Understanding this manual implementation will help you debug issues and appreciate why NumPy is so much faster for large matrices. Let's wrap this up. The most important thing to remember is that matrix dimensions must be compatible. The inner dimensions need to match. Also, matrix multiplication is not commutative, meaning the order matters. In real projects, always use NumPy because it's heavily optimized, but understanding the manual implementation gives you deep insight into what's actually happening. Now you've got the foundation to tackle neural networks, computer graphics, and so much more. Great job!